All right, let's go ahead and get started. Hello, everyone. Thank you for joining the first of a four-part partner spotlight series with ZONTAL on exploring scientific data platforms. What if you could get the answers to any questions you have around your scientific data, new and old, when asked, regardless of which department or location you work with? Wouldn't that be faster than spending months requesting information from a multitude of data sources or individuals? What if you had the full trust of the data, again, new or old, even if you don't work in the laboratories where the data capture occurred, say for IP protection purposes or quality analytics? What if the data you received for your answer was fully trusted so that you can make decisions without questioning the integrity or the meaning? And finally, what if you could deploy generative AI on your internal data and trust the insights it provides to your staff without question? Today, and through this Spotlight series with our partner Zontal, you'll learn the value of scientific data platforms and the basics, how they differ from traditional SDMS systems, and the value of ensuring this foundational data layer is set to future-proof your data, and hear about some specific value-add use cases. In other words, you'll learn how deploying a data preservation platform can bring you closer to making all those what-ifs a reality. My name is Lisa Richard. I am a director here at CSols, responsible for strategic services, data and analytics, as well as partnerships. I'm very happy to kick off our partner series and introduce you to Dan DeAlmeida, who is the Vice President of Product Management and Marketing for Zontal. Welcome, Dan. We're really glad to have you here with us today. Why don't you go ahead and
Thanks,
kick
Lisa.
the series off? Yeah, it's great to have you. Why don't you go ahead and kick
Yeah,
the series off with some platform basics?
sounds good. So ZONTAL is a digital preservation system. Sounds a little different than what people are used to saying, but essentially, if you think of the concepts of an SDMS, scientific data management systems, we take it a little bit a step further, right? I mean, if we take data in from instruments, we try to make it standard, we make it fair, findable, accessible, interoperable, and reusable, right? I mean, we always have to spell out these acronyms. And then we allow people to view that data from long-term perspectives. And all of that is either visualized or enhanced with metadata and context along the way to make sure that there's traceability to the original source.
How does it truly differ, though, right? When some people say it's just a glorified SDMS?
Yeah. If you think of where SDMS started, it really started around archiving, right? Data archiving. And data
Mhm.
archiving had very specific challenges back in the day. So you'd have an instrument, it'd be tied to a computer. That computer would have data that was generated from the instrument, put into a folder. And eventually, when you process too much data, that computer started slowing down due to the amount of files in there. So people would take those files, they would move them out of the folder. Then they'd run out of storage on the computer, so that they take it manually and they put it into an external source system. So SDMS was really created to remove those manual steps along the way. But
Mhm.
essentially, it required that you restored all of that data to the original system so that you could reprocess that. Now, it doesn't sound bad when you have an NMR or just a single GC, but when
Mhm.
you have many NMRs and you have many GCs and you're trying to do an audit or an investigation, now you need to return all of that data to the original sources.
Mhm.
It has evolved, obviously, throughout time, but we've changed it up a little bit more to go a step beyond just the standards there. We've added the ability to ingest it from many different sources. So we're not only doing instruments, but we're doing experimental data from ELNs. And we'll talk about that in a different chat. But we're also taking all of these and putting them into a standard format. As a backbone, we use the allotrope simple model. And
Mhm.
so if those of you who aren't familiar with allotrope, I know you're going to ask the question. Allotrope is a consortium that started with the large pharmaceutical companies to really standardize the way um, things were talked about in the lab, right? They
Mhm.
create these different working groups. They define these ontologies so that when you say a sample, you know what a sample is. And they look at it from different scientific techniques. If you flow cytometry, if you're looking at just the different working groups. Just recently, they've extended it to experimental data as well. So we're working with them on that. So we use that as a backbone so that every set of data that comes in has a standard format, which takes it to a different level, right? So now you have all this data that's structured, enhanced with metadata and context, and in a standard format. On top of that, now we can visualize all of this data. So if
Mhm.
you think of, again, we go back to how many NMRs you have, how many GCs or HPLCs, probably from different vendors. Now you can take those different vendor data and overlay them in the same tool. Now, we are intended to be a read-only tool. So if you ever need to reprocess or reanalyze, you do have to go back to the expert tool. But long-term preservation-wise, you can do most of your investigations directly in ZONTAL.
Okay, so going back to the kind of the basics, I think a lot of folks, when they hear allotrope in a model, they think I have to harmonize my data to the allotrope, and that's a massive effort. So can you talk a little bit about the transformation of that or the options that they would have in considering it so it doesn't seem like a huge barrier?
Yeah, it's not a huge barrier for us because that's just our default process. We happen to use allotrope, but we do that as part of the ingestion process. So as we're taking in data from different producers, again, instruments, ELNs, whatnot, we are standardizing it for you so that it's not a burden on our clients in order to standardize it prior to the data ingestion into ZONTAL.
Okay. And I think the other thing that's challenging, so we talked about the shift from traditional SDMS to a data preservation system. And I think the value of a multitude of formats, the value of not having to reprocess, I think that speaks towards decommissioning, which is a later in our series, a later session in our series. But when we think about the different layers that folks have to consider today, how do data lakes fit in? Is that just yet another platform? And what would be the difference on that end that would justify having this and that in an organization?
Yeah, the data lakes was probably another step towards the evolution of where we're going. It started as, okay, so we have SDMS, everyone has all this ability to ingest this data. What if we put all of our data in one centralized place and we'll call it a data lake?
Mhm.
And so they started these projects to have structured and unstructured data in there. What they didn't really consider along the way, again, was the standardization and the ability to find the data afterward. So you can use AWS or some other repository as your data lake. But in order to find that, now you have to create your own interface. And that's either through a SQL interface or someone's building and you're developing an actual user interface to access that data. Now you can put Power BI or Spotfire or any of these other tools on top of it. But again, still some custom development that goes
Right.
alongside of your data lake that now you have to have a developer and they have to understand the linkage between all of that data in the lake. So we're eliminating a lot of that by already having that standard, having the interface, having the ability to do that. Now, we do have pre-built applications. So NMR, flow cytometry, chromatography, mass spec, that you can go in, you visualize all this data. And on top of that, we do provide the ability to do extensions. So we are an API first company. So if you do have a favorite tool and you have a group of developers that are on staff, which most people do, you can always use Spotfire, Tableau. We have a SQL interface that you could do that with. The intent is really to have a central place that all of the data can be accessed and prepared for future use.
And so let's talk a little bit about that. Does Zontal own that data when it's in there? If you have a central spot and now I've entrusted it in, I've transformed it, does that take away some of my ownership of that or some flexibility with I have? We say that it helps future proof, but how does it really?
Yeah, great question. Short answer is no. Zontal does not own that data. It is still your data. And again, the goal of some of this to have a standard format. Allotrope simple model is a JSON structure. It's a little bit more complex than that, but it's a JSON structure in the end that you can actually export all of your data directly from our interface. So we've already considered long-term. Maybe someday Zontal needs to be decommissioned as well. And so you can export that data and it's in a human readable format that you could take into a different system that can read the allotrope format again.
Okay. And so let's get if we're sticking to creating the reality of all these what ifs and we look at realizing the potential of Zontal, I think there's this view that it's yet another daunting layer that's going to take a lot of effort and it's kind of a pipe dream in terms of adding it. But what I've heard through working with our clients and through working with you guys in this partnership is that it actually facilitates it, right? The enablement of that data, it actually decreases the amount of time. And we're going to talk later in the series about decommissioning and some specific use cases, but can you talk a little bit about that process of getting to the point of actual ingestion, where it's automated data transformation, right? Some people think that's kind of a dream. It's hard to get their hands around. Can you speak a little bit around that?
Yes, I think one of the benefits of systems like Zontal is we can act as an integration layer. When you think of your LIMS systems, you think of your ELN systems out there. More than likely, there have been custom integrations between the ELN and LIMS to the same exact instrument. And then if you have a different instrument, you probably recreated those over and over again. So you have a multitude of repeated integrations to the same points. It's a many-to-many situation, but as an integration layer, we can normalize that with a lot of the work that we've already done. So if you go to our website, we have a list of integrations that we've worked in. It's about 500 right now. A variety of different techniques, file-based, API-based, SDK. So we call them parsers and integrations along the way. But all of that is built, and we continue to build that library to really simplify how we can bring up systems. So now if we go back to that ELN, that LIMS situation, we've worked with ELN vendors to actually build in an integration so that in the ELN, you click a button, you ingest the data from the instrument into Zontal. Zontal standardizes it, normalizes it, captures it, keeps that original data immutable, takes that result and passes it back to the ELN. So now you have that full round trip. Sometimes the user won't even know that they're using Zontal. It's just there as the integration layer. But again, from an auditability perspective and an investigation perspective, we have all the data, we have all the audit records. We can trace it back to where it came from and where it went for long-term use.
Nice. I think you touched on, we don't have too much time. We have a few minutes left, but you touched on two things that I want to hit on. One is, I think when people hear the word data preservation, they think of decommissioning, right? I get my old data out and that's it. But I think really what Zontal is it's both decommissioning and legacy data as well as active preservation. That's on an ongoing basis. Would you
Absolutely.
agree or would you have
Yeah,
more on
absolutely.
that?
You can continue to maintain all of the systems that you're doing. So again, we're not an analyzing or processing tool. We are a preservation tool. So a lot of the systems that we're actually ingesting data from are still active. Active instruments, active ELNs. If you do want to decommission it, it just makes it easier. Now you don't need to maintain those original licenses to the original tools to access your data or to view your data from audit
Oh my
perspectives.
God.
Now,
Benefit is endless
so
with that.
yeah, exactly. So now
The
you've
second point,
consolidated all your
oh, go
license
ahead.
costs. Yeah,
Go ahead.
yeah.
Sorry.
No, I was going to say now you've consolidated all your license costs there.
Oh my God, the total cost of ownership. I think that's the other question that I get often is just, Lisa, don't add another layer, right? We
Yeah.
can't, we've got too many in our system already. And what we try to help them see is they can actually decrease the layers. They can decrease the total cost of ownership. And then the other value I think that's difficult to see. So we talk about data preservation, but the foundational elements of Zontal are also in the active world with that integration, right? It's kind of a data exchange. And I think you touched on it where you can go back and forth between to alleviate the need for point-to-point integrations.
Correct. Yes. Bidirectional communication is one of our abilities. We have a module called operations that is actually more of an instrument request. It's really interesting. So we can actually take data and sample sets from ELN, send it down to Zontal, build an analysis request, send it down to an HPLC, for instance, which is actually the entire sample sequence. The HPLC runs, it executes, it processes data, outputs data, Zontal ingests it, sends it back up to the ELN. Right, so now you have that full round trip and that traceability of all that data along the way.
I think it's hard for folks to visualize that, just given the old traditional models. And so I look forward to folks joining us for the rest of the series to kind of dig into that a little bit. I know we're going to go through some specific use cases around ELN data and the value that goes across. From a basics perspective, what's kind of the last thing that you want folks to leave with in the last few minutes here, or a few seconds?
Yeah, this is really about that digital sustainability of data, right? We're looking to make sure that you have access to the experimental data and it's not lost for generations to come, right? So that's how we're going to learn is just to maintain the records. Good or bad data doesn't make a difference as long as we can find it and it's stored in the proper way, then it's reusable to create all the therapies that we want in the future.
Well, I think one of the biggest benefits, I think that's great from what you've talked about, is just the accessibility of it, right? The opportunities are wide open. And if we could realize those benefits where folks anywhere in the organization trusted the data because of that transformation, the allotrope, et cetera, and shared meaning, I think that the value is endless. So I really appreciate you joining us. I encourage everyone on the call to join for the next session, which is next Wednesday. It's going to be focused on a specific use case for IP protection, and we look forward to talking with you further. Thanks so much, Dan, for joining.
Thanks, Lisa. Take care.